flipped, then the probability of having a head is 0.5 and probability of having a tail is 0.5. So you'll say that your hypothesis is that the coin is fair, and then you conduct a test and you find out whether the hypothesis should be accepted or rejected based on certain parameters that we will discuss in our following slides. And then another example is that I formulate a hypothesis saying that all vehicles on a certain road, any road, they travel at a speed of less than 40 kilometers per hour. That is my hypothesis based on the observations, or based on any study, or based on any whether I studied the data, whether I studied a report, whether that is my observation. Now that is my null hypothesis, and I will check this null hypothesis using the data set, and then conducting z-test or t-test. And then another null hypothesis could be that I say that there are two different medicines. It's, let's say, aspirin and other medicine which is for the headaches, Advil. And my hypothesis is that the effect of medicine 1, aspirin, and then in relieving the headache, excuse me, is same as the effect of Advil. Now that is my hypothesis. Then I'll collect the data, I'll conduct either z-test or t-test, and I'll see whether my hypothesis is correct or not. So all these are null hypotheses. Now, whenever we have a null hypothesis, a basic hypothesis, there is always a chance that this hypothesis could be rejected based on the results of our test. So we always have an alternative. We always have another an opposite hypothesis to our null hypothesis, and that is called alternative hypothesis, and it's represented by H1. So whenever we have a null hypothesis, we always have an alternative hypothesis that negates our null hypothesis, or it's opposite to it. So we always accept or reject a null hypothesis in favor of the alternative hypothesis. So the hypothesis that differs from or is opposite to the null hypothesis is called alternative hypothesis. For example, the coin is not fair, so the probability of having a head is less than 0.5. Or the null hypothesis to the second, the alternative hypothesis to the second null hypothesis is that all vehicles on a certain roadway, they travel less than 40 kilometers per hour. Or all vehicles on a certain roadway travels more at a higher speed, like more than 40 kilometers per hour. And then to the third one, the alternative hypothesis is that there is a difference, or the medicine 1 is not effective as medicine 2, or medicine 2 is not effective as medicine 1, whatever it is, but medicine 1 is not equal to medicine 2 in relieving the pain, and vice versa. So this is quite self-explanatory that whenever you have a null hypothesis, which is your basic hypothesis, which is your basic problem that you want to solve, or the results that you want to see, you always have an alternative hypothesis. So for example, you say that the mean rainfall in Karachi in the month of July is 5 inches. Now that is your null hypothesis. Then immediately your alternative hypothesis would be it's less than 5 inches or it's greater than 5 inches. So to all null hypothesis, there is always an alternative hypothesis. And then this is type 1 and type 2 error is something which is inherent. It's not always the case that whatever hypothesis that we make, whether we accept a hypothesis or whether we reject a hypothesis is always correct and we don't make errors. There are always probability, there are always chances of making an error whenever we are taking a decision, because it's based on certain sample, and based on that limited sample we make a conclusion whether to reject or accept a hypothesis. So there is a probability, there is a chances that we are making errors. So if we reject a hypothesis when it should be accepted, then we commit type 1 error. So let's say we conduct a z-test, and our null hypothesis is that the average height of man in Karachi in Pakistan is 65 inches. Then the alternative hypothesis is that the average height of man in Pakistan is less than 65 inches. We conduct a z-test or t-test depending upon the sample size we have. And then our results show that that we are rejecting our null hypothesis in favor of the alternative hypothesis. So, which means we are committing type 1 error. It's not that we are committing, but there is a probability that we might be committing type 1 error. So, if we reject a hypothesis when it should be accepted, then we are probably there are chances that we might be committing a type 1 error. On the other hand, if we accept a hypothesis when it should be rejected, then there is a probability that we are committing type 2 error. So it's either or. If we reject a hypothesis when it should be accepted, we are committing type 1 error. If we accept a hypothesis when it should be rejected, then there are chances that we might be committing type 2 error. In either case, a wrong decision in judgment has occurred. It depends that how wrong it is. It could be like 0.1%, it could be 0.2%, it could be 0.001%, it could be 50%, but there are chances. So, and it also depends upon how good or bad our data set is. Now, in order to test of hypothesis to be good, to be more confident, in order that we should be more confident about whatever decision we are making, tests should be designed to minimize the errors. The way you should make your hypothesis, the way you should formulate your hypothesis, and the data that you should collect. It is very highly recommended that you should make minimum errors. You try to minimize the errors in collecting the data, in formulating the hypothesis, in conducting the analysis. And then an attempt to decrease one type of error causes an increase in another type of error because it's either or. And the only way to minimize both type of errors is to increase the sample size. Of course, everything comes back to the sample size, but again, the more sample size you have, the better your judgments would be, the better your results would be. However, it's not always possible to have a large sample size, and that is why we do probability, and that is why we do statistics, because we are not always talking about population. Population it could be huge, so we always talk in terms of samples, and then sample which is representative of the population. So to minimize these errors, it's better that the first thing is that your hypothesis formulation should make sense. It's something which is achievable, and then the way you conduct your test should be not ideal, but fairly close to ideal situation, where you try to minimize all the errors, have a better control over your experiments, have a better control of over your data collection process, and have a better understanding of your data. You know what you are going to do. It's not that you just picked a problem, and so it's always necessary to have an in-depth knowledge of the problem that you are going to solve, so that you know that these results make sense or these results don't make sense. And then another important thing whenever we are doing hypothesis testing, or whenever we are developing a model, and that is the level of significance. Now, what is level of significance? In level of significance, in simple words, your level of confidence over your statement. You say that, or over your data. You say that I am 95% confident about my claim. I am 90% confident about what I am saying. I am 99% sure what this is the mean, or this is the median, or this is the problem that I have formulated. I am 99% sure about it. So these are this is your level of confidence. Now, in testing a hypothesis, the maximum risk that we can take to make type 1 error is called level of significance or significance level. I just talked about confidence. So if I am 95% confident about my data set, if I am 95% confident about my hypothesis, then I am taking 5% chance, just 5% chance, and that is called level of significance or significance level, which means I know that there are 5% chance that I am either making type 1 error or type 2 error. So that is called your significance level. The significance level is denoted by alpha, and commonly we say that we are 95% confidence. So our significance level is 100 minus 95, like this is 5%. So our significance level is 5%. That is, we are allowing only 5% chances of error in our experiment. Or the other is we say that we are 99% confident. Yes. Yeah. Do you have any question? Okay. It's up to you. There is no defined way of, there is no defined value for that. It depends on what confidence level you select. We usually go for 95% and 99%. It could be 90% as well if you are not very much sure about the data that you have collected. So it's up to you. But the most commonly used are, no, 60% is too much. If you are 60% sure, no, which means you are not much sure, so better not to have that data. Shouldn't be less than, recommended is shouldn't be less than 90%. At least you should be 90% confident about your experiment. 60%, it's too low. Whatever, like all the statistics books that I have referred to, all the problems that I have conducted or referred to so far, the most commonly used is 95%. 99% is too good. Like I'm 99% sure that I'm correct, is too good, which means you really have to have control over what you are doing. And then 90%, okay, if I'm not that sure, if I'm allowing, which 90% means I'm allowing more, like 10% error to occur, which means I'm less confident, but of course, no, it's not 60%. So here, alpha is 0.05, which means I am allowing 5% error to occur in my decision, and then I am saying that my alpha is 0.01, which means I am allowing 1% error in my decision. So if, for example, an alpha of 0.05 is chosen in designing a decision, then there are about 5 chances in 100 that we would reject the hypothesis when it should be accepted, making a type 1 error. That is, we are 95% confident that we have made the right decision. In such a case, we say that hypothesis has been rejected at the 0.05 significance level, or whatever our claim is, whatever our decision is, whatever we have, whatever statement we have made, if there is a 5% probability or chance that it would be wrong, or 1% chance or 10% chance. So understand that confidence level is one thing, and then 1 minus confidence level is your level of significance, which is that level, at that level of significance, at that level you allow an error to occur, or it's a chance to have an error in your decision. So if you are 95% confidence, then your level of significance or your alpha value is 5% or 0.05. If you are 99% confidence, then your level of your significance or alpha value is 0.01. And if you are 90% confident, then your significance level or alpha value is 0.1. And when we'll do the when you are in our